Hi, and thanks for coming to see my virtual presentation on investigating the role of DRD4 in the development of post-traumatic osteoarthritis. So this project all started when we were doing a drug screening. So we engineered human chondrocytes with the type 2 collagen promoter driving Gaussian luciferase. And we used 3D cultures to identify a compound that would stimulate type 2 collagen. And we screened a natural product library, and that compound was aromaline. And in the analysis, we found that aromaline was likely targeting dopamine receptor D4, or DRD4. We confirmed this with another agonist of DRD4, and so upregulation of type 2 collagen. And then the thinking was that it plays a role in the homeostasis of type 2 collagen. In the knockout mouse that had been developed for study of neurological diseases, they hadn't reported any skeletal phenotype. So I'm thinking that maybe if we perturb the system, we might be able to see something. And we have been using the non-invasive knee injury device to create an ACL tear. And we hypothesized that because DRD4 contributes to collagen homeostasis, if we knock it out, then that would exacerbate the post-traumatic osteoarthritis severity following the ACL tear. And we looked at things like gait, pain, MMP activity, micro-CT, and histology. So this is a kind of the timeline setup. We had to actually cryo-recover the mice, and we got heterozygous mice, and we did harem breeding to get wild type and knockout lidomates. So we did this on both wild type and knockout, and we aged them to 10 weeks old, and then we did gait and pain, so minus 2 weeks and minus 1 week, and then we gave them the ACL tear, and then did gait and pain again at 2 days with an MMP analysis at 4 days. Gait and pain at 2 weeks, 4 weeks, and 8 weeks, and euthanized the mice. So the gait and pain, we used the DigiGate setup, and because we nared the mice, the legs would actually show up in kind of the paw print. So we collaborated with an AI group reprocessing of our DigiGate images, and then kind of darkened the nose and the tail and the legs to allow us to get the paws on the treadmill. We also did pain assessment, or the withdrawal assessment, using the von Freya assay. So this is, you poke the feet with a fiber that has different stiffnesses, and the stiffer the fiber, the more force that it produces on the foot. And the sooner the mouse withdraws its foot, the more it's sensitized to the pain. So we created the ACL tear using this device. So it's a non-invasive knee injury device, and the mouse is put into this with the knee in this cup, the ankle in the holder there, and up here above it is a motor that presses down really rapidly and tears the ACL. So we can see that it's preload and compression to get the ACL tear. And then 4 days later, we inject the MMP Sense 750, and we can see this nice bright fluorescence in the injured leg, where we don't see anything in the uninjured leg. And it goes out to the 8-week time point, at which point we take the knees from both the injured and the uninjured joint, and we did micro-CT. We segmented out the femoral condyle, the tibial plateau, and did the medial and lateral portions of those. It is the micro-CT that really gives us the most interesting data. And here we have it for the medial tibia. On the y-axis, we can see the bone volume fraction, and you can see that the injured leg has a much lower bone volume fraction than the uninjured leg. And that's statistically significant for both the knockout and the wild type. But then in the lateral tibia, you can see that it's significant in the knockout, but not in the wild type. When it becomes really interesting, though, is when we look at the femoral condyle, and then we see there's a significant effect on the DRD4 knockout, but not in the wild type. And this time, there is a significant difference between the two genotypes. And the same is true in the lateral side of that. And the way I'm thinking about this is from a biomechanical perspective. The medial side of the joint is the most loaded and overloaded, so that's the one that deteriorates the quickest, with the lateral side deteriorating more slowly. And that theoretically, this is a model of how severe the arthritis is. We can say that we are having an effect due to the DRD4 knockout. The other metrics were not so clear, because this is quite a harsh model. And in the MMP, it was clear that we had injured the mice. In the von Freya assay, it was also clear that we had injured the mice in the early time point, but they lost that by the end of the study. With the gait analysis, there was a change in stride length at the early 2-day time point, but that was again rapidly lost, and it wasn't a robust assay. So if you want to see more about that, please come to my poster and have a chat. I'd like to acknowledge all of my co-authors, and most of them are people that did the work, so mostly undergrads and med students. Dr. Kean is the AI specialist, and her grad student and undergrad have been working on the video processing.